All right. So this is an extension video, meaning this material will not show up on your power assignment, but it will show up in your portfolio work. And it's also just a good, interesting thing to know. There is something called the ambiguous case when you're using the law of signs. So if you haven't already opened this GeoGebra link from Canvas, please do that now, because I'm going to ask you to play along as we look at different cases where this can happen. So ambiguous just means unclear. So there is a time when you're using the law of signs where maybe, just maybe, there's more than one way to do things. Let's take a look here. So we're going to consider several cases. Now, for what we're doing here, we're going to label this side here as B, lowercase b. And I'm going to call this corner angle A. We're then going to look at what's possible. How many triangles can you make? Is it 0? Is it 1? Is it maybe more than 1? Given these different scenarios. And that's what the GeoGebra is going to help us with. So let's start with this first one, where A, so we're going to make another side of a triangle over here, is less than B sine A. Yikes. Well, you're in luck. I've set this up to make it a little easier for you. So here you can adjust the length of side A. And this here is B times the sine of A. So B sine A is this H number we're talking about. And notice you can move things around. So you can change that angle. You can change then how long this side is. And you can also click and drag to move this around. So what I want you to do is to move things, keep this angle acute. But other than that, just make it so that the side A is less than this B sine A. So this number needs to be less than this number. And here's what we're going to try and answer. How many triangles can be made if that's the case? And I hope I can convince you that no matter what you do, there's no triangle that can be made. This third side, this side A, simply isn't long enough to get down to here and close off the triangle. So if this is the case, if side length A is less than this B sine A, then there are 0 triangles that can be made. So back to this note sheet here. I'm just going to throw a side on here that's a little short. And I'm going to make here then 0 triangles are possible. The other side is just not long enough. That's not, I think, super exciting or anything. And by the way, just in case you're curious, where does this B sine A come from? It's just measuring this. It's just measuring how far it is from this point up here straight down. So if A is less than that, you can see it's just not long enough to reach the other side here. Okay, let's look at a few more cases. What if this opposite side A is equal to B sine A? So here we go. Here we go. This time I'm going to make it equal to B sine A. So that would mean that it's going to be exactly the length here of this green segment. So I'm going to try to make it as close as I can. That's about as close as I can get here with the slider. And what you should see is that, look at that. It's just long enough to get down, close it off, and make a perfectly right triangle. So there's only one triangle that is possible, and it's that right triangle. So if A is exactly equal to B sine A, then what you have is this. You've got a right triangle, and there's only one possibility for that. It's got to look just like this. Now, to the meat of it, here's the interesting one. This right here is the ambiguous case. It turns out, even before we look at it, I'm going to let you know, there are 2 possible triangles in this scenario. And the thing is, unless you're actually physically looking at it, you don't know which one it's going to be. Let's see what happens. If I think about my other side here, so B sine A has to be less than this side length A, but then A also has to be less than B. So on our GeoGebra, I need my A to be bigger than this H number, but smaller than this B number. So tell you what, I'm actually going to make my B a little bit bigger. So I need to get my A to be between 4.385 and 6.499. So I'm just going to move it, say, there. Now, the reason we say it's an ambiguous case is because something quite magical happens. Take a look at this. If I go like this, I've got a triangle. A very nice one, as a matter of fact. But if I go like this, I also have a triangle. It's a super skinny one, but it's a closed off triangle. So this angle didn't change. This A side length didn't change, but I could have either the super skinny one that would still meet the law of sines, or I could have this one that would meet the law of sines. And it doesn't matter as long as your side length is in this range. So between the 4.385 and the 6.499, you're always going to have, even if I go real close to something like this. So I could have, look at this, there's a triangle, here's another triangle. So a skinny one and a wider one. If I take it closer to here, I got a wider one and a less wide one. So two different triangles in all those cases. That's what we mean by the ambiguous case. If you don't have more information, you just don't know whether it's supposed to be this version or this version. That's unclear and therefore ambiguous. And that's the way you check it. Is your side length A greater than the height of that right triangle, but less than the length of that side that you already know? There is one other case, and that is if your A is bigger than your B. So here my B is 6.5, so just make my A something bigger than that. Then it's no longer ambiguous. You're not going to get a triangle over here. You only have the big old wide version. So we're back then to there being just one possible triangle. So I'm going to sketch in something like that. So again, here's my B, here's my angle A, and here's my big old long A side. I'm back now to just one possible triangle. So some things that we want to be able to check. B sine A is just the height of what would be an altitude from this point down to here. So if A is less than that, it doesn't reach and you have no triangles. If A is exactly equal to that, then you have that right triangle. If A is just a little bit bigger than that, but still not longer than the B side, then you have two possibilities that come from kind of swinging that arc around. But then if A gets bigger than this other side, you're back to one big old wide possibility. Now, you'll notice the example we looked at here, this angle A was acute, meaning it was less than 90 degrees. What if A is more than 90 degrees? Then it becomes much easier. If you have an obtuse angle right here, then one of two things is going to be the case. If your A is less than your B, it doesn't reach. If your A is more than your B, it's going to reach exactly once. And so back to here to wrap this up, if A is less than B, I'm just going to mark here again side B in my obtuse angle A, side B in my obtuse angle A. If A is too short, you just have no triangle. And if A is super long, meaning longer than B, then you are going to have one triangle. So it'll take you a while to be comfortable with this. Quite frankly, I still have to every once in a while review how this works. But that's the breakdown. This is the ambiguous case, this one right here, where you have two triangles. That's the one that you need to keep track of, where your side A is a little bit longer than the height, but not as long as the other side you know.